Hello, this is OCR Further Statistics. We're in Non-parametric tests 2 and the third video on the Wilcoxon rank sum test. As usual, it's a good idea to stop and work some things out for yourself or review what's been covered. Whenever you see this symbol, pause the video and follow the instructions before continuing to watch. You may be aware of systems like PISA that try to compare the school systems in different countries. This is incredibly difficult because students are taught different things at different stages. So experiment design will be very complex. In any case, though, only a sample of the students of each country are tested. So let's look at the principle of comparing two samples of students from different countries. Essentially, all we are doing is testing to see if the distributions are different. But usually there is an implicit assumption that the distributions have the same shape. That means that any difference will mean the medians are different, so we can word our hypotheses in terms of the medians. Our hypotheses will be: null hypothesis, the median scores are the same. Alternative hypothesis, the median scores are different. Of course, we might want to do a one-tailed test, in which case the alternative hypothesis might be that the median is higher or lower. We've talked about assumptions, but what we are not assuming is important too. For this test, we don't need to assume that the populations themselves are normal. And crucially in this test, we don't need to know the median of either population. This means the tests can be used in a wider range of situations. So here's the basic idea. We merge the two datasets and rank the combined set smallest to largest. We look at the rank sum for the smaller sample and consider its size. Is it significant? Then, as usual, we draw our conclusion in context. OK, now let's work through this carefully. Here are the null and alternative hypotheses and the chosen significance level. Often the samples will be of different sizes. The notation is that the smaller size is m and the larger size is n. In our case, m equals 6 and n equals 7. So the smallest value has rank 1. I've colour-coded my data so it is easy to see which is from which dataset. This would be particularly important if the dataset was large enough that I actually needed to merge them in order to do the ranking. With a small set like this, I could keep the two samples separate and still get the ranking correct. Now we find Rm, the sum of the ranks of the smaller sample. We need to compare Rm with the value of m multiplied by m plus n plus 1, take away Rm. What are we doing here? Well, the second value is what we'd get if we ranked them from largest to smallest, and we want to get to the same conclusion whichever way we do it. So, for our example, m times m plus n plus 1 is 6 multiplied by 7 plus 6 plus 1, which is 84, and we subtract Rm from that. We then choose the smaller of Rm and the value we've just calculated, 41, and so W in this case is 41. We're working with n equals 7 and m equals 6, with a two-tailed test at the 5% level. For each pair of values, the table gives the largest value of W, which will lead to rejection of the null hypothesis. We've got a critical value of 27 here. Our value of W is bigger than the critical value, so too big for us to reject the null hypothesis. We draw our conclusion in context. There is insufficient evidence to suggest that the median scores of the two countries are different. Here's a summary of the steps in carrying out the Wilcoxon rank sum test. Pause the video while you check that you understand all the steps. Rewind if you need to go over any of it again. Note that the formula book has a summary of the method. When you are practicing the test, have this open in front of you and check that you can do it correctly without looking at anything else. That's the end of this video on the Wilcoxon rank sum test. In the next video, we'll look at using a normal approximation for large samples.